In 1978, in a dry riverbed in northern Tanzania, a team of fossil hunters found something they were not looking for. Not bones, not teeth, footprints. Dozens of them, pressed into a layer of ancient volcanic ash, frozen solid for millions of years. And there, in the middle of the trail, the unmistakable marks of two small creatures walking side by side. Not on all fours, walking, upright, on two legs as naturally as you or I. The ash they walked through has been dated to 3.5 million years ago, which means these were not humans as we know them. Their brains were small, their faces were ape-like, and yet they moved through the world the way we do. The question is not just how they walked, it's how an animal built for swinging through the trees ever ended up on its hind legs in the first place. To understand, you have to go back 7 million years, to a time before footprints, before any of this began. At that point, our distant relatives were creatures of the forest canopy. They were spectacularly good at what they did. Long arms, curved fingers, gripping hands and feet, built to hang, swing, and scramble through branches high above the ground. But the forest floor was a different story. Coming down to walk across open ground, they did what modern apes still do. They leaned forward, planted their knuckles, and shuffled along on all fours. It worked, but it was exhausting. Every step of knuckle walking burns enormous amounts of energy. And that cost mattered more than ever, because the world was changing. Over hundreds of thousands of years, the climate turned cooler and drier. The great unbroken forest that had stretched across Africa began to splinter into smaller patches, separated by open grassland. For a forest creature, that created a brutal problem. The food was scattered now, spread across distances. To reach it, you had to cross ground that was exposed, sun-baked, and dangerous. And knuckle walking is an expensive way to travel. Somewhere in that squeeze, a few individuals started doing something different. They stood up.
We can see the evidence in a few precious bones. A skull from Chad, 7 million years old, with the hole at its base. The place where the spine enters the head shifted forward, as if this creature held its head upright over a vertical body. Leg bones from Kenya, 6 million years old, with the internal structure thickened along the underside. The kind of strengthening you get when a body bears weight on two legs over and over again. These were not walkers in the modern sense. They still lived in the trees, but they could stand, they could balance, they could take an upright step when they needed to. Then, 4.5 million years ago, we meet a creature that embodies the transition perfectly. Her name is Ardi. She's the most complete skeleton of this era ever found, and her body tells a strange, contradictory story. Her hips and lower spine were built for standing upright, but her feet were different. Her big toe stuck out sideways, like a thumb, perfect for gripping a branch. Here was an animal caught in the middle, trying to serve two worlds at once. She could stand and walk on the ground, and she could still climb, clutch, and hold on for dear life in the canopy above. For over 1 million years, this was the template. Upright, but not committed. Then, around 4 million years ago, the balance tipped. A new kind of creature appeared, one that made a choice. Down here, on two legs, all the time. She is known to the world as Lucy. Lucy's skeleton is only about 40% complete, but it's enough to show how thoroughly her body had been redesigned. Her spine curved into an S shape, bending inward at the lower back so that her head and torso stacked directly over her hips. Her pelvis had become short and wide, a bowl-shaped platform, and the muscles that attached there had been repositioned. Instead of pulling their legs forward like a quadruped's, they now worked like cables, stabilizing her hips with every step, keeping her balanced on a single leg as the other swung forward. Her thigh bone angled inward from hip to knee so that her foot landed directly beneath the center of her body. And her foot itself was no longer a grasping hand. Her big toe had straightened, aligned with the others, no longer built to grab a branch but to push off the ground. Her foot had developed a spring, an arch that absorbs shock on landing and releases it like a coiled coil when she pushes forward. Here's the thing about that arched foot. When you walk on two legs, every step sends a shockwave up through your heel, through your knee, into your spine. An arch absorbs that impact and turns it into forward motion, like the spring in a car suspension. Without it, you'd be jarred to pieces. Lucy and her kind became the first true walkers, and the proof of it is written in the ground. Those footprints at Laetoli, the ones that started this story, they belong to creatures like her. Look at them closely, and you can read the whole event. A deep impression where the heel struck, a clean transfer of weight along the outside of the foot, rolling toward the ball. Then a powerful push off the big toe. It's not a crouching, shuffling gait. It's a full, efficient, upright stride. 3.5 million years ago, on a single afternoon, two small figures walked across a plain of wet ash, and the earth kept their movements forever. But here's the question we still haven't answered. Why? Why give up the safety of the trees, the skill of a lifetime, for the vulnerability of standing upright on open ground? The answers are written into the physics of the body. Walking upright is efficient. When you walk on two legs, your body swings over your leg like a pendulum. Momentum does the work. Your center of mass arcs up, then falls forward, and gravity carries you into the next step. Over long distances, that saves a staggering amount of energy compared to knuckle walking. For a creature whose food sources were scattered farther and farther apart, that efficiency was the difference between reaching the next meal and not. Standing upright also helped with the heat. In a sun-scorched savanna, a quadruped's back is turned toward the midday sun, absorbing heat across its entire body. A biped stands tall, exposing a much smaller surface area to the overhead rays, and lifts its body up into cooler, moving air where sweat can actually evaporate. And then there's the simplest answer of all. When you stand up, your hands are free. Free to carry food, free to carry an infant, free to pick something up and take it somewhere else. The moment you don't need your hands to walk, they become available for everything else. But this was not a free lunch. Standing up came with a price. The S-curve in the spine puts pressure on the lower back. The redesigned pelvis, wide and shallow to support upright balance, narrowed the birth canal. Every one of us, from the first walkers to today, inherited those costs. Back pain, difficult childbirth. It is the tax that every upright species pays. Which raises another question. If the price was so high, why keep paying it? Because the payoff kept growing.
2 million years ago, a new kind of walker appeared. Longer legs, a fully arched foot, a stride that was smooth, powerful, and seemingly endless. These were the first creatures built not just to walk, but to go. And go they did. They left Africa, they crossed open plains, followed rivers, and spread across entire continents. At a site in Kenya, there are footprints from this era, 1.5 million years old. Compare them to the ones at Laetoli, and you see the transformation complete. The arches are high and defined, the big toe is fully aligned, the stride is long and modern. To a trained eye, they are indistinguishable from footprints left by a human being walking today. These were endurance walkers, and later, endurance runners. The same body that learned to walk could run for hours, chasing prey until it collapsed from exhaustion. The feet, the spine, the pelvis, the gluteal muscles, the whole machine could carry a creature across a distance no other animal could match. Think about what that meant. For the first time in the history of life on this planet, a species could outlast its prey. A species whose strength was not speed, not claws, not teeth, but persistence. The ability to keep going when everything else had to stop. Standing up was never just about walking. It was about having hands to build with. It was about carrying food home. It was about covering vast distances. It was the foundation upon which everything else was built. Tools, cooperation, migration, and eventually everything that makes us who we are. Every mile you've ever walked, every road you've ever traveled, every meal carried home, every tool raised in a working hand, it all traces back to a single strange decision made millions of years ago by small creatures who stood up on a shrinking patch of forest and decided to take a step. And at Laetoli and the ash, 2 of them walk past us still, side by side, upright, moving forward, doing the one thing that would change everything. They took the first step. The rest of the story, we've been walking ever since.